And welcome, function folks, for the start of the end. This is the first day in our last chapter, and as you'll see, just about everything we've seen in this chapter, we've seen before, or we will see in this chapter, we've seen before. It's a nice way to end the course. It's review, mostly, so let's get into it. Um, Here we have a couple of functions. These are just linear functions, lines, and we want to state or calculate. This is the sum function. We'll remind you of what this means specifically in a second, but if you remember, f plus g at minus 2 is exactly what you would think would be. It's the individual two functions at that point as well. So what's f at minus 2? Well, I can do that work here, or I could do it in the margin. F at x of 2x minus 3. I take out the x and I put in minus 2, and I get negative 4, negative 7. And g at minus 2 then is 4 minus minus 2, which is 6. Then I have minus 7 plus 6. It looks like it's minus 1. So, well, could have I found what the sum function was first and then just substituted in? Absolutely, you could have done that. And in fact, that's more the technique that we're going to use for b here. This is f minus g at x is just f at x minus, it's a difference function, g at x, and f at x is 2x minus 3, and g at x is 4 minus x. Collect up some like terms, 2x minus negative, maybe another step here. There we go, 3x minus 7. And so that is what we call the difference function. Right? This is a new function made of the other two. And I could have done that over here and then substituted in minus 2 to find my answer, but either way is fine. And we did this stuff. This last unit is maybe a little bit different than the first unit in that we're really interested in this idea of making new functions and what we can do with our new functions. I think of it not as combining functions chapter. I think of it as a modeling chapter. And I don't mean runway modeling, and I don't mean model airplanes, although model airplanes is pretty close. We're going to use functions to model new situations. And as we'll see, it turns out, the models that we have so far aren't great. So what we'll do is we'll find new ways to combine the functions that we have. Okay, example 1. Given the pair of functions, determine the sum function, graph all three. And there's a little recall of the notation, right? This notation, this means a new function, and this is how we make it. So sometimes we say it's this, right? This new function is the old two added, but we also just use this new notation. So don't be afraid by the new notation, because we have seen it before. And so we want to determine the sum function and graph all three. Well, there's the two functions. They're two rational functions, so we're going to have to think back to that chapter. Well, this is kind of, like I said, a good review. If I want to find the sum function, I want to find f plus g of x. That's the sum function. That's f at x plus g at x. It's just the two functions added, right? Well, how does that work? How does that work? Well, I'm adding two fractions. I need to get a common denominator. Right, the common denominator is the smallest expression that both things will divide into. Lovely. Multiply the tops by the missing term. Multiply the top by the missing term. And then on the top here I have x minus 4, multiply that out, minus 3x, multiplying this through here, skipping a step or two maybe, but we don't have to show all of our steps. Like terms there, negative 2x, lose 4, lose 9 is lose 13 over my common denominator. And then they ask us to graph all three. And notice, one way I could do that is by taking my new sum function that I just found, this function right here, and graph it using the algorithm that we learned uh, from Unit 2 on rational functions, right? Vertical asymptotes, horizontal asymptotes, zeros, all that business. I could use Unit 2 techniques, or we could use what we learned earlier in Unit 0 about combining functions graphically, and that's what I'm actually going to do, because these are two grade 11 uh, transform functions, right? So I'm going to set up my grid here. There we go. Lovely. Some scale. Great. And how does this work? It is this f at x is that function moved left 3. Right? And so I can say, I've got my vertical asymptote at x equals 3, because what happens is the old vertical asymptote of the parent function gets moved left 3. Great. And there's no stretches, nothing like that. So the point that was at 1, 1 gets moved left 1, 2, 3 to there. The point that was at -1, -1 gets moved left 3, 1, 2, 3 to there. And then the asymptotes are there. So this is f at x. Right, this is f at x equals 1 over x plus 3. And then this one is, let's see, where can I, running out of room here. I have g is this function flipped and stretched vertically. Stretched vertically, factor 3, and moved right 4. So let me think about that. The asymptote has been moved right 4, right there. So that means the asymptote's going to be here. And instead of this point being moved, this point that was here, 1, 1, being moved right 4, it has been flipped and stretched by a factor of 3. So where the distance was 1, it's going to get stretched to -3. And in fact, all the points get stretched by that much. So it's a little more off of the x-axis than we'd expect it. And there's another point up here. Same, it was there, right? But it gets flipped and stretched and moved right. There's the other nice point. And of course, I could get some more points. And normally when we were drawing these, we wouldn't extend them so much, but I want to, I want to make a point about how we combine functions graphically. So to get the new function, let's see, what color am I going to use? I'm going to use black. This new function, f plus g, remember, one thing I can do is I can just go for each value of x and add the little distances. So for instance, if I start at x equals 0, this little bit is, I don't know, like some sort of fractions. This little bit plus this little bit, I add that little blue distance on top of the little red distance. So blue is there, red is there, and I could put that on top of that, like that, to get this new point. And I can keep doing that, right? There's f plus g, and I'm going to put the G on top of the F and just add graphically. Right? Okay, well, I can keep doing that. This is just a little bit more, and I am going to, even through here, what happens through the asymptote? Well, the red one's not defined, so then the black one's not going to be defined. And in fact, this function sort of gets taken over by the red one because I'm just adding a little tiny bit to all these numbers that are shooting off to positive infinity. So it's going to look something like that in here. And notice here, what's going to happen on the other side, I've got this little tiny blue number added against, I guess you could say, that bigger negative. Like -3 isn't that big, but you get the idea. And so this line's going to be just a little bit back from the red line. And notice here, it's just going to be, a little bit underneath, like this. And it almost looks like the two functions together almost look like just the red one because the blue one is so small there. And if I go to the left, some more interesting things happen here. Notice there's that blue plus red is about there, blue plus red maybe there, and I'm just guessing now a little bit. I'm just going along and adding some points together. And the same thing happens with the asymptote here, which, by the way, makes sense from unit 2, that we would have two asymptotes, -3 and 4. Yep, two asymptotes. Something very interesting happens over here, however. Notice that the blue plus red here is going to bring this back just a little bit, so it's going to be on the other side of this. This -1 plus a little bit is going to be here. But notice what happens just because this one is a little bit further off than the blue one. At some point, I'm going to get a blue plus a red, positive amount, negative amount is going to be bang even. You see that? Somewhere in here, because of the shape of the graph, the red one is actually a little bit further off, and the blue one's a little further out, that at some point, when I add those together, red plus blue, somewhere in here, is going to give me 0. That's pretty cool. And who knows where it is? Well, yeah, we know where it is, and I'll explain why we know where it is. But then notice the red one, after that point, after the point when they're equal and opposite apart, the red one's going to be further off. So I'm going to get something that looks like this. It's going to go up and back down like that. Remember, it's like there's a little pimple there. We don't know how far up that goes. And that always bothered us about how low these go. But there's my graph. This is the graph of f plus g. By the way, this intercept, where is it going to be? Where's the x-intercept of f plus g? Well, we did this back in Unit 2, right? This is where the output of the function equals 0. And as long as, remember how we solved this? See, this is great review. What great review. As long as x isn't equal to -3 or +4, I can multiply. I multiply here, and that gets multiplied up there, and it's 0 equals -x minus 13. 13 goes on the other side, and I divide by -2, and I get -7, no, not -7.5, -6.5. And so I know that the x-intercept of my combination function is just this one. It's the only spot. And how does my graph look? -1, 2, 3, 4, 5, 6. It should have been there instead of there. Actually, my graph was pretty good, even though I've got the big, thick smartboard pens to work with, and you did a good job on yours, I'll bet. Is there anything else I want to say about that? Does my other Unit 2 stuff hold? Well, Notice that the top is smaller degree than the bottom, so I know right away my horizontal asymptote is y equals 0, and it looks like that's what I've drawn. My vertical asymptotes are x equals -3 and x equals 4. This is all Unit 2 analysis, right? Unit 2 analysis where the technique that I used was Unit 0 analysis, and actually more like what we're doing this unit. Okay, I do have more to say about this example, but I'm going to come back to it in part 2.